Hi everyone, this is Sahil from QuickNode. In this video, we will learn about compressed NFTs on Solana. And we will also learn how we can mint these compressed NFTs on the Solana blockchain. And once they are minted, we will learn how to fetch them using Metaplex's digital assets standard API. So without any ado, let's jump into it. NFTs have been very popular in the blockchain space and especially on Solana blockchain. And despite of Solana being a very cheap blockchain in terms of gas fees, deploying or minting multiple NFTs, let's say thousands or millions of NFTs, can result into very high fees because of very high rent fees. So that's where compressed NFTs comes into pictures. So compressed NFTs are relatively newer standard compared to your traditional NFTs. And as the name suggests, the NFT data like metadata is actually compressed and stored in the blockchain state. And because of that, compressed NFTs can be 1000x cheaper at scale compared to your traditional NFTs. They uses straight compression and can be accessed via a Merkle tree. So basically metadata of compressed NFTs are hashed and stored in a Merkle tree, and then the hash of the root of that Merkle tree is stored on chain. So compressed NFTs uses concurrent Merkle tree, where each leaf, as you can see in this figure, x8, x9, x10, and x11 all represents a single NFT. So in a collection, let's say that you have thousands of NFTs. So there will be thousands of leaves, and then there will be branches. As you can see over here, x4 and x5 are branches. So x8, x9 will be hashed to form x4, x10, x11 will be hashed to form x5, and then x4 and x5 will be hashed to form x2. So the hash of x2 is what's stored on chain. Basically, that is the proof of the NFTs within that particular collection. So each collection will have their own Merkle tree and own root with hash, which will be stored on chain. And because the entire metadata is not stored on chain, just the hash of the Merkle tree's root, which contains the hashes of the metadatas of multiple NFTs within that collection, is stored on chain. So that is what makes compressed NFTs very cheap and efficient at scale. But the thing is that to retrieve compressed NFTs, you will have to go to a complex procedure of rerunning the state of the blockchain. And to make this process simpler, a lot of infra provider index this data. Now, the NFT standards in the Solana ecosystem have evolved quite a lot. And with newer standards like compressed NFTs, it kind of becomes tricky to retrieve and fetch these NFTs. And that is why we have Metaplex. And with Metaplex's digital assets standard API, we can fetch all kind of NFTs using one unified API. And now let's see how we can mint and fetch these compressed NFTs. So over here we have a TypeScript script to first create a concurrent Merkle tree for our compressed NFT, then mint that compressed NFT, and after that, once it's minted, fetch the NFT metadata and display that NFT metadata using Metaplex's DAS API. So what we are doing over here first is we are importing a bunch of libraries. As you can see, we are importing a lot of libraries from Metaplex, libraries like Umi bundle defaults, Umi, which are high-level toolkits, which helps us interact with Solana and Metaplex. We are also importing MPL token metadata library to be able to work with standard Solana NFTs. Then we are importing MPL bubblegum library. So bubblegum is the Metaplex equivalent of gummy roll program of Solana, which keeps track and helps us work with concurrent Merkle trees. So bubblegum program of Metaplex and gummy roll program of Solana works with each other. Then we are importing some other stuff from Umi library again. Then we are importing Lamports per sol from Solana Web3.js, which helps us, to calculate Lamports, which is a common Solana construct. And then we are importing DAS API library so that, we can work with DAS API. After that, we are initializing our QuickNode endpoint over here. So this we will need to replace with our QuickNode endpoint with DAS API enabled. So to enable DAS API on your QuickNode endpoint, what you need to do is simply go to your Solana endpoint on your QuickNode dashboard, then navigate to add-on section, then scroll down a little bit Then navigate to tokens and NFTs section. And after that, click on explore and install that add-on. So once you install Solana Digital Assets and Standard API, you will be able to use DAS API on your QuickNode endpoint. So as you can see, the add-on is installed. And if you want to check out all the RPC methods which are available with this add-on, you can just navigate to quicknode.com/docs, then navigate to the Solana section, then navigate to Marketplace add-on section, and after that, just navigate to Solana DAS APIs section. And over there, you will be able to find all the RPC methods which are available with the Solana DAS API on QuickNode. So let's get back to our code. And after that, we are initializing a new instance of Umi with the following plugins of Umi so that these can work with our endpoint. So let's copy the endpoint URL from here. Let's replace this with our endpoint URL. And then we are initializing our wallet from our wallet secret, which will go over here. And in reality, whenever you are doing this, please do not paste your wallet secret over here. Just import it via an environment variable. Or if you are planning to push this code or share this code with anyone publicly, do not paste your secret over here, or make sure to remove the secret whenever you are sharing the code publicly. After that, we are configuring our NFT metadata, and this is an old URI, so we will need a new one. So what you need to do is you can upload a NFT or an NFT asset. I'm using IPFS via QuickNode. So first I will have to upload my NFT asset. So that is what I'll do over here. And I will get the IPFS URL and make sure that it's working fine. All right. So I'll copy this URL and open the metadata file and paste it over here. So in metadata, I have the name of the NFT, I have the symbol, description, image, URL, which is this. Attributes, I have a trait type and value. Trait type is background and value is blue. So let's save this file and upload this metadata file on IPFS as well. All right, so it's uploaded, and once it's uploaded, let me copy the IPFS URL of this file as well and paste it in the URI variable over here. All right, so now we are all set. Then calculate depth for NFTs, create a large enough tree based on the NFT count. Then we have calculate max buffer size, which based on the depth of the tree will create or allocate a appropriate buffer size. So these are the two functions which will be used to create the Merkle tree. Then we have a function called print asset, which will be used to fetch asset information once it's minted. And if the asset isn't readily available or immediately available, it keeps on retries. And once it's found, it prints out multiple things from the asset. It checks if it's compressed or not. It prints out JSON URI or fetches the JSON URI, fetches the files, and also fetches image URL. It also fetches name, symbol, etc. Then we have our main function, which will combine all of the functions which we saw earlier and mint our NFT. After that, fetch the NFT details and display it. So first, what we are doing is we are just checking the wallet balance over here. Then we are calculating the Merkle tree parameters using the calculate depth for NFTs and calculate max buffer size functions, which we created earlier. Then we're doing a partial caching of upper layers of the tree so that we can do faster lookups using canopy depth. And after that, we are calculating the storage cost for our NFT data, which will be hash of the Merkle tree on chain. So that's what we are doing over here. We are calculating the node sizes, we are calculating the index size, then maximum required space over here. Then we are also checking if our wallet has sufficient funds or not to cover the storage fees. After that, we are finally creating our Merkle tree over here and sending our transaction to create the tree. After that, we are verifying if our transaction was successful and if the Merkle tree was successfully created or not. So then we are printing some attributes of the Merkle tree. After that, we are minting a test NFT using the metadata which we declared earlier and our wallet. And after that, we are fetching the details of our NFT. And finally, we are running the main function. So the actual RPC method used to fetch NFTs is get asset. Get asset is a RPC method of the Solana DAS API. This method is called using QuickNode's endpoint and used to fetch NFT details. Now let's run the script, mint our NFT and fetch that NFT's detail using Solana DAS API. So let's go to our terminal, to tsx app.ts. You can use any TypeScript compiler. So as you can see, the Merkle tree has been initialized and the transaction has been sent to create Merkle tree. Now you can see the Merkle tree has been created and our test NFT is being minted. So once it's minted, we will fetch the details and output it. So as you can see, it's minted and the details are fetched. Now, if we look up this transaction on Solana Explorer, we should be able to see that it was a compressed NFT minting transaction. So as you can see, it's a compressed NFT and this is the original artwork which we uploaded. So this is how you can mint a compressed NFT and then using Solana DAS API on a QuickNode endpoint, you can fetch its details. So hope you learned something from this video. Give it a thumbs up, subscribe to the QuickNode YouTube channel, and I'll see you in the next one. Bye bye.